Thanks, everyone, and welcome to my presentation on putting chaos into continuous delivery. And thank you for this warm welcome. And today I want to talk a little bit about how to increase the application resilience and how to also evaluate it before you increase it, actually, to find out if there is actually the need to increase it. My name is Juergen. I work at Dynatrace, and I'm also one of the maintainers of the Keptn Etzlstorfer project, which I will be using as kind of the demo software for this presentation. It's open source, but you can also think of others if you want. So I would just demo this on this application. So I could not join you in person, so I wanted to make it obvious where I'm located right now. I'm based in Linz, which is in Austria. And it would be a nice 7-hour drive to go to Krakow today. And the closest I've ever got to Krakow was actually Bielsko-Biała. This was the closest I could reach Krakow, but hopefully in the future, I'm able to join you at one of your conferences. So let's talk about the actual topic for today. So in a typical CD process, continuous delivery process, you have your, let's say, multi-stage environments. You have dev, staging, pre-production, production, whatnot. It really depends on your organization. And you might already do some performance and load testing with JMeter or Locust or Artillery or whatever testing frameworks you're already using. But you cannot really make sure that that production always stays safe, even though you do a lot of testing. But there will be a point in time when production is breaking because of a lot of different dependencies. And kind of what I want to advocate for today is not wait for the point in time when production goes down, but actually use mechanisms, use chaos engineering, and use it already in pre-production environments, maybe even in the dev environment, and execute chaos there. And also how to find a way how to evaluate the chaos that you're executing. So the idea is really to shift left in your CI/CD pipeline and introduce chaos. Actually, it's more in the CD pipeline and not so much in the CI part, but really introducing chaos early on in your stages, at least in the one before production, to make sure to evaluate the impact of chaos on your applications and find a way to increase the resiliency of your applications. So how can you improve resilience and increase it? What I already said in the beginning was load tests and performance tests, they should be augmented with some kind of failure scenarios. It's an important part that you do load testing, and I think there is even an engineering discipline called testing in production, which you can do. But I also think doing chaos tests in earlier stages would really help you to increase the resilience of applications, because it's not only your application that can fail. Actually, in nowadays stacks, in cloud native stacks, but also in large on-prem stacks, it's not only your application. You have a lot of different dependencies. There might be a database. Obviously, there might be some kind of eventing. There might be always networking. There might be, if you're running on Kubernetes, there might be the managed or even not managed layer of Kubernetes. And of course, there is the whole infrastructure layer. So it's a lot of different components, and you can test for resilience of all these different components, and you should test. And only on the very top of this is your application. And you need to define some kind of chaos experiments, what you actually want to evaluate. And usually, when we are developing software, we are mostly working with assumptions that the network is reliable. The latency of the network is 0. Our bandwidth is infinite. So we have a lot of different assumptions, and with introducing chaos into CD pipelines, we can actually break these assumptions, and we can work with real-world, let's say, scenarios and real-world conditions when the network is not reliable, when the pods in the application we are starting is crashing, and because of some kind of infrastructure failure or whatever. So we really have to make sure that we test different kinds of scenarios when the application is under load, and then evaluate how our application is actually affected. And as said, there is a kind of discipline with testing in production, which is totally fine. And there's also this discipline of game days, where you use chaos experiments and you define, okay, today or next week, Wednesday, we are going on a game day and we will experiment with chaos in our production environments, and we will evaluate the impact, we will do a postmortem. So this is all great, but even more important, I think, is that you have some kind of thinking on how to automate the experiments to run them continuously, not to run them only on game days and kind of jeopardize your production environments only in game days, but have this as a continuous evaluation and as a continuous experiment to really kind of move from chaos experiments into chaos tests that are part of your pipeline. What you would also do with load tests, for example. You would not just do load testing in your production environments, but you would do this early on to ensure that whatever configuration you bring into production and the sizing of the cluster and everything that you need to make sure that it's production ready is actually battle tested for production. And the same goes with chaos engineering, for example. So how can we evaluate this, and what are the basic measures how we can do so? In this presentation, we are going to use service level indicators and service level objectives, and I will explain just in a second what they are. But the basic idea of introducing chaos is to first define a steady state condition, to define kind of a hypothesis, and then introduce a fault into the application. It can be introducing the latency in the network. It can be basically cutting the network. It can be just doing a CPU hog and increasing CPU saturation to 100%, and then take a look at how your application behaves. There can be different ways of this fault. And then you have to evaluate, do my service level objectives, are they still met? Is my quality still the desired quality of my application? Or is maybe the failure rate now a little bit higher? Or is the response time now way worse than it was before? But if the conditions do not change, if the SLOs stay the same, you can consider your application as resilient to this kind of chaos. And if not, you have found a weakness and you can now work on improving this weakness. So in this presentation, we are going to use LitmusChaos, which is an open source chaos engineering framework. It works very well on Kubernetes environments. And since I'm a maintainer of the Keptn project, which also works very well in Kubernetes environments, we combined those two projects. We worked together with both communities, and we did an integration, and that can be now just being used out of the box. And putting Litmus or whatever chaos engineering framework, like what is out there, like Gremlin or AWS FIS or whatever into chaos engineering framework you want to use, you might want to use this also in continuous delivery pipelines. And I would say the more you are in the dev side of the environments, maybe you just run short chaos experiments. You would not run like hours of load tests in your dev environments. And the same is true for hours of chaos in dev environments. But the closer you're going to production, the more mature and the longer your chaos experiments should be. So they really simulate real world conditions. So they can be like light chaos in early environments and more heavy chaos in later environments. And you evaluate them with different thresholds, the impact of the chaos on your application. So let me now talk a little bit about how we can use the concepts of chaos in CI/CD, and how you can do this, for example, with Keptn, which is an open source CNCF project. And the goal of Keptn is really to orchestrate the application lifecycle of your applications and microservices. And I want to focus today on one specific part of Keptn, which is the SLO-driven multi-stage delivery. So we want to have a multi-stage delivery, and we want to make sure that we only can promote from one environment to the other, let's say from dev to pre-production or from pre-production to production, if some quality criteria are met, and this is based on service level objectives. And everything we do is declarative, so we will be using YAML. It's all based on GitOps, so it's basically with both projects, it really well fits into the whole Kubernetes world where you have a lot of YAML, and this is how we are configuring our workloads and configurations nowadays. So taking a look on a, let's say, continuous delivery or on a delivery pipeline would mean to take a look at thousands of lines of code, because usually they grow and grow and grow. You include more and more tooling into them. But with Keptn, it's a little bit different. We separated the actual tooling from the process. So in the shipyard file, and Keptn in German language, Keptn sounds like the captain of a ship. And so we have a lot of those terms from the nautical terms, let's say. So we have the shipyard, which defines the process and our environments. So let's say we have a shipyard, and it has, in this case, a chaos stage and a couple of sequences. So first we want to do a deployment, which is part of the delivery sequence. We will run some tests, and we will do an evaluation. We do not define the concrete tooling in here. So this gave us also the option, the flexibility to include, for example, more tooling later on, to not only have performance tests, but actually also do some chaos tests at the same time. So it's really a separation between the process and the tooling. It's, let's say, even transparent to the tooling. We do not define it here, so we can just exchange the tooling with another concept, which is called the Keptn's uniform, where we map the tool to a task execution, let's say. And everything is based on cloud events. It's event-based. You could even say it's data-driven, since all these events, they have all the data that needs to be included for a tool to kind of execute a task. So to make this a little bit more concrete, for deployment, for example, you could use Helm or other rollouts or whatever deployment tool you might already have. And Keptn will kind of augment the cloud events that are sent to Helm or Argo with a deployment strategy, with the artifact you have to deploy, with the version of the artifact you have to deploy. All this information will be sent from the Keptn control plane to the actual to what we call the execution plane. So for Helm or Argo or whatever tool to pick it up and work upon this. For testing, we can include load testing software such as JMeter, LitmusChaos, Artillery, and or Locust service, Locust performances, and LitmusChaos, of course. So we can include just tools that will react whenever there is a test event sent. Usually it comes after the deployment. So first we do a deployment. Once this is finished, we trigger the tests. And in our example, we want to trigger tests, load tests, plus chaos tests. And we can do this with this event-based approach very easily, because we don't have to rewrite the pipeline. We just add another tool to the test phase. And of course, we need to evaluate. And I will be talking about the evaluation just in a bit, because that's the important part where we talk about service level indicators and service level objectives. So a service level indicator is something like a metric. We can really think of it as a metric, something like the, let's say, the error rate of login requests. So this would be the service level indicator. In the service level objective would be some kind of objective or goal for the indicator. Something like the error rate for login requests has to stay lower than 2% within the last 10 minutes, for example. So in Keptn, we are combining these two concepts. The service level indicator is really just a list of the metrics, and we can just combine it with PromQL with Prometheus queries, how to fetch the data. And then we can use all of our service level indicators in the service level objective file. And we can make use of this and just define, for example, the probe success percentage, basically let's say the availability of the service has to be higher than 95% within a given time frame. Or the duration, basically how fast the application can respond to the probe, has to be faster than 200 milliseconds. So we can write our service level objectives for some kind of a service. And the beauty here is it's not tied, the service level objective file is not tied to one specific data provider. So we can easily move from Prometheus to some other tool if we want, or have more tools feeding the Keptn quality gates. And it's not tied to one specific microservice. So we can even use the quality gate for more than one microservice, even for a whole project, for example. So how can we trigger it? What we want to do is we can use the Keptn CLI, or we can use just the Keptn API to trigger quality gate evaluation for a given time frame. Keptn will reach out to the data providers, will query the data, will evaluate the data based on the criteria we have here. For each passed criteria, it will get full points. For each passed warning criteria, it will get half points. And then in total, Keptn will calculate the score. And this score basically is your, let's say, resilience score. And you can then decide if you want to move it on to the next stage, or if you want to keep it in one specific stage. So bringing all these concepts together, and I have to take just a look at the watch here, but I think I have 10 minutes left, so maybe we can even do the live demo instead of the demo on the slides. But let me just explain what will be happening. So we do have a chaos stage. We are deploying a sample application with Helm into a chaos stage, which is just our sample stage. Then Keptn will make sure to trigger tests, both LitmusChaos tests and Locus performance tests. So we have some load. We want to evaluate the resilience of the applications and the impact of chaos under some load. We don't want to have an idle state and then we just do some experiments, but we don't really know what was going on, if there was any traffic on our application. Once both tests are finished, Keptn will make sure to trigger the quality gate. We will fetch the data from Prometheus. Actually, everything will be done automatically. And then the evaluation of the quality gate will give us a thumbs up or a thumbs down. And with a thumbs up, we can promote it to the next stage. And with a thumbs down, we should keep it in this stage. Actually, we should improve. We should work on improving the resilience. So we have a couple of, let's say, moving parts in this application. I've deployed this into the Google Kubernetes engine. I have Keptn running there. I have LitmusChaos running. There is also Prometheus running and configured to check the availability of the potato application. And when we trigger the experiment, when we trigger the CD pipeline, we will first deploy a new version. Then we will start the locus tests. We will also start, we will trigger the LitmusChaos, which will go ahead and delete one instance of our application. Prometheus will still be querying or trying to query and then send probes to our application. Some of them probably will fail. And after both the locus test and the Litmus tests are finished, Keptn will do the evaluation again based on the data from Prometheus. So I still have a couple of minutes, so actually let me switch to my CLI here and just send, let me take a look, and this looks good, and let me send a deployment event to Keptn. So it's not that important what I'm typing here exactly, but what I'm doing is I'm sending one deployment event to Keptn, which will deploy a new version of my potato application. And we can take a look also in the Keptn's bridge. So right now, the deployment, actually, it was the version that I also did as a preparation for this talk. So I know it's just it's successfully deployed, and now Litmus tests and locus tests are started. And for this, we can also take a look, and it was going really fast here. We can also take a look on what's going on in my Kubernetes cluster, and we can see there is a pod delete, which is my actual chaos experiment. This is already running, and this was initiated by the Hello Service Chaos Runner. These two parts are orchestrated by Keptn, and these two parts come from LitmusChaos. And my application, the Hello Service, which is part of the potato application, now it's not ready yet, so it needs a while to come back. It was basically just killed as when I was running this experiment, and it needs a while to come back. We have defined here a pro or a readiness pro, that it takes around 30 seconds for the application to be ready once it's being created. So it needs some kind of 30 seconds for it to be ready. So all those probes that are sent to an application within the first 30 seconds cannot be, they won't return the HTTP 200 because they're all failing. So what we can see also here is so both the locust service and the Litmus service, both integrations have not yet finished. So while I'm talking, the Litmus integration already finished. So it did execute the chaos, it did wrap up all the resources that have been created during the chaos phase. And we still need for the locust performance tests to also finish. Usually they take about 2 minutes. This is what I've configured in this short demo. So for 2 minutes, we are hitting the application with load. We are also doing one experiment with chaos, where we deleting one instance of this application. And what we can see is once both are finished, Keptn will automatically do the evaluation. We can see we got 0% of the quality score, because both the probe success percentage and also the duration was not satisfying. So we needed at least 95% of all the probes to be successful, and we could not satisfy this. So one, let's say, easy way to improve the resilience of my application is both of my SLOs actually check for the availability of my application. So why not increase the replica set? So with this, we can make it, let's say, high available, and let's just change it from 1 to 3. And this is just part of my cloud event that will be sent to Keptn, and I will trigger another deployment. So with this, Keptn will again pick up this cloud event and will send the information to the deployment integration. And my deployment integration is Helm. So Helm is already picking up that it should now scale up the application. And as you can see, it's creating 2 more instances. So I will be, just in a couple of seconds, I will be having 3 instances of my application running. As soon as all 3 instances are running, the deployment is considered as finished and the testing will start. And once the testing is starting, we will also see that Locust will be started up again, and the Locust integration, the Litmus integration for the chaos tests will again go ahead and delete one of my instances here. I do not know which one, but I just know that one instance will be removed. And I just marked all 3 of them, and we should see one just being terminated in a couple of seconds. So it's again the same workflow that I did earlier, but this time I have 3 replica sets, and thanks to the load balancing mechanism of, we can already see one is terminated, and Kubernetes is making sure to create another one. And also thanks to the load balancing mechanisms of Kubernetes, there should be no traffic sent to the application, to the pod that is not ready. So actually this pod will not be serving any probes right now. It will just wait, Kubernetes will wait for it to be ready before it will send any requests to this pod. We can go back to Keptn, take a look on our latest run. So we can see the deployment was finished. Both tests are still running. So once Locust has wrapped up all the resources it needed for the experiment, Litmus, and also Locust finished up sending load to my application, we should get another quality evaluation, and we should hopefully see a green quality indicator, maybe close to 100%, as this should give us a successful run of our quality gate, as we increase the resilience of our application just by having more replicas running. This demo is working very well for increasing the replica count. But if you, for example, have something like the response time or the failure rate, maybe scaling up won't solve the problem. So this is something where you really have to take a look at your applications and at your services, and you can then decide what has to go on what are the right steps to increase the resilience of your applications. But with running chaos tests and with running load tests, you can really make sure to evaluate the impact by using service level objectives. Let's just give it maybe 1 more minute or 1 more second for the Locust integration to finish. And it was just finished here. And we can see this time our performance evaluation, actually it scored 100%, as all of our probes could return successfully, and also the duration was really fast, as we had at least 2 instances of the application running all the time. So I'm going back to the slides just to wrap up, and I'm skipping the parts that I was doing live right now. And the cool part for today is actually, although I'm not in Krakow today, the story or the actual real world implementation of what I've showed here was also influenced by our friends from Krakow, actually by Adrian and Sebastian, both working at GitOps, and they also worked with us on doing this integration, and they're already using this internally at GitOps to evaluate the resilience of their applications. They're using this in 3 different phases, with light chaos and with no chaos, light chaos, and heavy chaos. And basically light chaos, they shouldn't see any impact when performing light chaos on their applications, but they expect to see impact when they're doing heavy chaos. This is just kind of a proof that everything's working fine for them. So the key takeaway is really, the idea is to establish a process of continuously evaluating the resiliency, not doing only game days and test runs and the chaos experiments, but really having chaos experiments as part of your CD. And you can use SLOs for evaluating them. Everything in addition to performance tests, load tests that you might already have in your organizations. I think I put a couple of resources here. For me, it's no problem to also share the slides. I can put them in the Discord channel. With this, I'm giving back to the studio, and thanks so much, and I'm looking forward to your questions.